Hello everyone, welcome to our new tutorial video on solving problem from thermodynamics. Let's start with reading the question. A conceptual question. This is a kind of question that require a conceptual understanding of an topic or a particular course. It's just kind of question that require only the conceptual understanding, rather like a question which require a vast knowledge of the course, like a challenge, problems and so forth, or computational problem that requires calculations skills. So the question: if a system is closed, can the system undergo a work transfer, b a heat transfer, c a mass transfer? Roman 1. Roman 2. Electric automobile travel at a constant speed. Take successfully the following two items as your system: a, only the electric motor including the battery, b, the whole car. Roman 1. Under Roman 2a and b, determine a, if the system is open, closed or isolated. Roman 2. The direction and sign of the heat transfer and work transfer, if any. And number 3. The change of energy content, dE, of the system, if any, is a change of energy content, positive or negative. Clearly state all your assumption. Roman 3. Consider an automobile traveling at a constant speed along a road. Determine the direction of the heat and work interaction, taking the following as the system: a, the car radiator, b, the car engine, c, the car wheel, d, the road and the air surrounding. So this is a problem that require the only conceptual understanding. So this we are trying to show how we are applying thermodynamics to take a system and to analyze the system, to know the work and heat interaction and so forth, the direction. So a solution. Let's start with the solution. Roman 1. Before we go and solve the question, we know a closed system is a kind of system that can only undergo a heat or work transfer without mass transfer. No work transfer in a closed system. An open system is a kind of system that has a heat, work and mass transfer. This is what we call an open system. And an isolated system is a kind of system that there will be no work, no heat and no mass transfer. So this is a three category of the system. So we have a closed system for these problems. So now therefore a, if that is the case, a closed system undergo work transfer, therefore the answer is yes. B, also it can undergo a heat transfer, so the answer is yes. And C, there will be no mass transfer in a closed system, so the answer is no. So that's it. Then Roman 2, we asked to take electric motor as a system. So the system, it is the motor, including the battery. So assuming this is the motor, so this is a motor. So a motor, the work of the motor, there is work actually of the motor is positive, that is greater than 0. That is, the work is done on the motor. The work is done by the motor, so the work is positive. There is no heat into or out of the motor, so heat is 0. So top okay matsala akwai matsala. So Roman 2a, we asked to take electric motor as a system. So our system electric motor. So Roman 2 so under Roman 2a, we asked to take electric motor as our system. So electric motor as our system, including the battery, so let's take this as the motor. Work is done by the motor, therefore work done by motor is positive. Work done by motor is positive, that is greater than 0. This is just a sign convention we apply. The work done by the system is positive, while the work done on the system is negative. And heat by the system is positive, while heat on the system is positive. So that is a sign convention we use in thermodynamics. So therefore, and also heat is lost, or heat is done by the system. So heat is done by the system, so the heat by motor is less than 0, that is negative. So that is two sign convention we use. Therefore we apply the first law of thermodynamics. By applying the first law, that is the change in energy of the system, that is the motor, will be equal to the work by motor minus the heat by motor minus the work by motor. So this will be the heat by motor is less than 0, something like is less than 0, minus, that is the work done by motor is greater than 0. To something less than 0 minus something greater than 0 is less than 0, that is negative. work done, the change in energy by a motor is less than 0. Change in energy is negative. So under A, Roman 1, as we can see, the system is closed. System is closed. Roman 2, since the battery is assumed to be part of the system, the change in energy of the system now is less than 0, since it's part of the system, the motor, the battery. So the battery has the same characteristic properties with motor, since they are all system. So if we take the battery as a system, nothing will change. Therefore the change in energy of the battery is less than 0, that is negative. Therefore heat will be generated and released to the work net by the system, that is by the system. So heat is 0, heat is negative. Then Roman 3, the change in energy by the motor, as I have calculated, is less than 0. That is what is the X in 3. dE by motor and the battery are all less than 0. So that is Roman 3. Then B, we take the system to be the whole car. The whole car is a system. So our system is the whole car. So taking the whole car as our system, so let's design something like this to be the system. So that is a car. So if this is a car, dE of the car is equal to dE of motor. So the work, there is a work out by the car, that is the work is done by the car, and also there is a heat which is generated by the car, so there is work out. So Roman 1 under B, the system is closed. The Roman 2, the heat is released by the car, therefore the heat by car is negative, that is less than 0. The Roman 3, by applying the first law, dE of the car is equal to the work net by the car minus the heat net by the car minus the work net by the car. This is less than 0, and also this is a work out by the car, which is also which is greater than 0, that is positive, is work out, so work out is positive, so it's greater than 0. So therefore we have something like less than 0 minus something greater than 0, so which is the whole sense is less than 0. Therefore the change in energy by the car is less than 0, that is negative, is negative. So conclusion, that's the conclusion they ask us to draw. The behavior of the world car and its motto is the same well taken as a system. Thus for each heat well release, that is the heat is negative and work is done by the system. So that is when heat is less than 0 and work is greater than 0, then the wall energy will be less than 0. So that is the conclusion. Then Roman 3 A, automobile travel at a constant speed. So we take our system, so let's take the system, that is the car radiator. So supposing this is a car radiator, and there will be a mass in at a temperature that is coming, and there will be a mass out at the exit temperature T out. So always by this the T out is less than the T in. So there will be so this is the assumption, the T out is less than the T in, so Q is to be loose. There will be a heat release by the system. So if T out is greater than the T in, then heat is to be gained by the system. That is a common sense. Therefore we have two conditions. If T out is less than the T in, then the Q is less than 0, work is 0, and the E so will be less than 0. If so, that's the assumption. But if T out is greater than the T in, then Q is greater than 0, work done is 0, so DE is greater than 0. That is the assumption. So let's take this as our car engine. So there will be a heat loss, and there will be a work out. So the heat is released by the engine, so heat is less than 0, and the work is done by the engine, so work is greater than 0. So that's the case. dE is what? Is Q, that is less than 0, minus work which is greater than 0, which is less than 0, by first law of thermodynamics. Then C. Now system. That is the car wheel. So if car wheel is our system, so there is a work in, the work is coming in, there will be a work a heat out. So work is coming in, heat is coming, work is coming in, so work is less than 0, and work is out, so Q is less than 0. So we apply the first law of thermodynamics. dE is the work minus the heat minus work, that is something like less than 0 minus something still less than 0. So less than 0 minus less than 0, that is, for example, I have this is like we are having we have a minus here, so we have a minus, still minus, so we have minus, so minus minus plus, we have a positive. This is like we may have, that is the work, for example, is minus then plus Q. So this condition, we have two conditions. dE is less than 0 if work is greater than Q, and dE is greater than 0 if Q is greater than W. So that is the condition. And D, system, the rod. So there will be no work on the rod or by the rod, so work is 0. Heat is generated between the tire and the rod at standard condition, so the temperature of the rod is greater than the temperature of the tire. It's common sense. So there will be a Q, that is a heat out, heat is released, so therefore the heat is less than 0. So we apply the first law, that is the Q, something less than 0 minus the work which is 0, so dE is less than 0. So then the last one is Roman E, the system, that is the surrounding air. So there is a heat from the engine to air, so that is Q in. So therefore if there is Q in, the Q is greater than 0, that is heat is gained by the system, and work then is 0, no work, so the change in energy will be equal to greater than 0 minus 0. So the change in energy is greater than 0. So that is the end of this problem. Thank you for watching.